Now, due to some temperature gradient, gradient matlab change only. So due to change in temperature, the refractive index of our atmosphere is not constant, but it is changing. You know that when I was teaching you about mirage. So the refractive index is given as a function of y coordinate. Okay. A is given 2 into 10 power minus 6 per meter. So they are asking a person of height h equal to 2 meter stands on a level surface. The person cannot see beyond n into 10 power 3 meter. Find n. So if you look at the formula for refractive index, what is this n naught? That is simple to understand. Put y0. If you put y0, your n will be n naught. So that means n naught is nothing but refractive index at origin. N naught is refractive index when y is 0. Okay, a is some constant, and you can also see as y increases, when they don't mention anything, positive direction of y will be this. So as y increases, your refractive index also increases. So light going this way is traveling from rarer to denser. So it will not go straight, it will bend towards the normal. Light going this way. Okay. So let us say this is ground, this is the surface, this is your x-axis, let us say ground, and this is your y-axis. Refractive index increases along y-axis. Okay. Now, suppose refractive index was constant. That is what we assume for air. For air, we just write 1. No. So if you assume refractive index is constant, then a person standing somewhere, he will see all the points, because this light will reach his eyes this way, this light will reach his eyes, this light will reach, this light will reach, this light will reach, this light will reach, this light will reach. Ideally, if you speak, this person will be able to see all, the whole up to infinity. Up to infinity, he will be able to see. If light is coming, strong light is coming. That's why stars you are able to see. But because refractive index is increasing, what will happen? Any light going like this will not go straight, because you imagine layers here, layers. So refractive index is increasing. So if you draw normal here, this light will bend towards the normal, towards the normal. Are you understanding? So it will bend this way. All these lights will not go straight, it will bend like this. That part is clear or not? First you tell me.
Clear, sir.
So if they bend like this, then you can clearly see that depending on his height, some light may not reach. Now, suppose he is standing here. Now let us talk about light from here. So some light will go like this, that will go like this. Some light will go like this, that will go like this. Some light will go like this, that will go like this. And the light which is almost grazing matlab the angle of incidence with the normal here. This is the normal, because the surface, the refractive index is changing this way, right? So this will be normal. So the light is almost hitting at 90 degree. So the light which is grazing, that will go like this. So for this light, the angle of incidence is almost 90 degree. This is called grazing incidence. So you can see this person will not be able to see now this point. Why? Because even this light is not able to reach. If this light is not able to reach, how this light will reach? Clear, students?
Yes, sir.
Okay. Yes, sir. If this light does not reach him, how this light will reach? So what he has to do, brother, come little bit nearby. So the moment he comes here, so this becomes the maximum distance up to which he will see, because beyond this point, this will go like that. So he will not be able to see. So it is falling at an angle 90 degree, okay, grazing it is. So if you draw a tangent with the normal, it will make 90 degrees. So angle of incidence is 90. And this light will go something like this. This is the path of the light. So what now you do, this is your y equal to 0, right? So at that point, it will have some refractive index. Let me call it n naught. And let me choose some other y coordinate. there it will have some refractive index ny. This point will have some coordinates x comma y. Now when it reaches this point, this is the normal, remember, because medium is changing this way. So this is the normal. So at this point, the tangent to this light will be like this. This is the tangent. So this is the direction at this point. This is the direction in which light was going. It could not go because it is bending. But at that point, it is trying to go this way. So this is your angle of refraction. This is your angle of refraction, which let me write theta. Okay. Now, from here to here, you can use Snell's law that I have explained in regular class also. The middle part can be neglected. So N naught sine I here must be equal to Ny sine R here. And R here is theta. Okay. So N naught is N naught because N naught is the reflective. N formula was what? N naught root over 1 plus AY. So N naught means value of refractive index when Y is 0. Put Y 0, you will get N naught. So that is N naught only. Sine I is 90, grazing incidence. This is called grazing incidence. Ny is refractive index here. For which coordinate? Y coordinate. So for Y coordinate, this is the refractive index. So N naught root over 1 plus AY. And this is sine theta. N naught cancels. Sine 90 is 1. So sine theta will be equals to 1 over 1 plus AY. Root over 1 plus AY. Try to remember, after finding sine theta from Snell's law, you have to try to find cot theta. How to find cot theta? Draw this triangle. This is theta. Opposite is 1. Hypotenuse is root over 1 plus AY. So adjacent will root over this square. This square will be 1 plus AY minus this square. That will be root of AY. Okay. Yeah. So cot theta will be, tan theta is opposite by adjacent. So adjacent by opposite. So cot theta will be this. Now why do I bring cot theta? That is because once you have found cot theta, at this point, this line that I made was actually the direction in which the light is trying to go. So that is the direction in which light tries to go. So this is the angle of refraction. But it also is the tangent to this path. So it is, if it is tangent, then if I can find this angle, which is easy because this is theta, so vertically opposite this is theta. So this is 90 minus theta. The slope of this line, the slope of this tangent at this point, slope can be written as tan of the angle made by tangent with x-axis, which is nothing but in differentiation dy by dx, because this is tangent at this point. So this becomes cot theta. That's why I told we need cot theta. If you substitute here, you will get root ay equals to dy by dx. So now you guys are very smart in integration. Separate the variables. So dy by root a root y equal to dx. Then integrate from this point to this point. So from 0 to x, from 0 to y. 0 to x, 0 to y. Root a will come out. I want integration. 1 by root x dx.
2 root y.
2 root x. Okay. So here it will be 2 root y. Upper limit y, lower limit 0. This will be x. Upper limit y, lower limit 0. Put upper limit and lower limit. This will be 2 root of y by a. This root a you can put inside. Right. This is x equal to x. So we need to find this maximum distance. Now let us say the person is standing here. Let's make it the person now. So this is the man. Now if this is the man, then this y becomes his height or not? It becomes
Yes,
his height, and this x becomes the maximum distance. this becomes the maximum distance beyond which he can't see. So basically I have to find the maximum value for the person to see the road. I just need to put in place of y h. So height given was
2 meters.
2 meter. A value was 2 into 10 power minus 6. So it will be 2 into 10 power 3 meter. In the question they told n into, so this must be your n. Okay, chalo, thank you all of you.
Thank you, sir.
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 Thank you.